Hello everyone, welcome to this update about the eventlet-removal initiative. I'm Hervé Barreau, and today I will share our progress for the eventlet-removal work in OpenStack. Just a quick note before we begin. You don't need to take notes during this presentation. Please sit comfortably and enjoy this presentation. All the details are shared with you in the description of this video. Let's start with the current status of our eventlet-removal initiative. This section will give you a global overview of where we stand. Here we can see the recent releases of Eventlet. Since December 2023, there have been several new versions released, 17 to be exact. The most important point to note is that the project has been under new maintenance since end of 2023, which is a positive sign for the community. This chart shows the cumulative commit history for Eventlet. You can see the significant increase in activity since the maintenance transfer in 2023. This renewed development effort is helpful for our transition work as we've been able to coordinate between new maintainers. Looking at our progress over time, this graph shows both the review activity and contributor growth on OpenStack for the Eventlet Removal initiative. We've seen steady growth in both metrics, indicating healthy community engagement with this challenging work. This pie chart represents our current progress on the migration. As you can see, approximately 40% of the affected repositories has been started their migration, and 60% yet to be started. Here's an interesting visualization showing which repositories have been most active in the eventlet removal work. Neutron and Nova are leading the effort, with Mistral, Glance, and oslo.service following closely. All these efforts from teams is helping drive our overall progress. This word cloud gives us another perspective on contribution distribution across projects. The size of each project name represents the relative number of commits related to eventlet removal work. Now let's move on to some recent updates from the upstream community. One of the most significant recent developments is the addition of the oslo.service threading backend. This is a critical piece of infrastructure that allows services to use standard threading instead of eventlet. The code to enable this is simple, just 2 lines as shown here. There's an ongoing discussion in the upstream community, initiated by Nova, about the timeline for officially dropping eventlet support in OpenStack. I encourage you to follow this discussion. All the links are in report I'll share with you afterward. Let's talk about some of the technical challenges we've encountered. Those are important problems, so please be sure to listen carefully. Problem number 1 is related to Python forking in multi-threaded applications. When using os.fork in a multi-threaded application, only the thread that calls fork is replicated in the child process. This creates potential issues when other threads hold resources or locks. Here's a specific example of how locks can cause problems when forking. If a thread acquires a lock, and then another thread calls fork, the child process inherits the locked state, but not the thread that could release it, potentially leading to deadlocks. Here is a living example of this problem with socket and deadlocks. You can observe the state of the TCP socket and its inheritance problem. The socket is inherited, but handler thread is missing, leading to blocked resources. The recommended solution is to use the "spawn" method from the multiprocessing module instead of direct forking. This creates a fresh Python interpreter process without the threading inheritance problems. Here's how to implement the spawn pattern in your code. Just 2 steps. Step 1. Set the start method to spawn. Step 2. Then create processes normally. You will get many benefits from this solution, namely, less bugs, clean process, no zombie threads. That's a win-win. Another interesting issue we've encountered involves Python's garbage collector. That's the problem number 2. This visualization shows how the garbage collector can sometimes interact unexpectedly with shared resources. We was thinking that it was an eventlet bug, but it's actually a Python bug. The garbage collector sometimes clears an object's contents by mistake because of how it handles circular references. This can happen even without eventlet. It shows up in Python 3.13, but not in Python 3.12. For now, Nova is impacted by this bug, but potentially over OpenStack services are also impacted by it. You can follow the discussion on the Python bug tracker. Before we wrap up, I'd like to acknowledge all the contributors who have been instrumental in this initiative. This is truly a cross-team effort that requires coordination across the entire OpenStack community and across our companies. Our mission is to help you to build sustainable, secure, and responsible software. We identify the technology that slow us down, put our users at risk, or compromise the reliability of our products, and we want to help you to replace it. Because your time deserves better than patchwork. Because our users deserve software they can trust. Because our technical choices shape the future. Join the Eventlet Removal initiative. Subscribe to this channel. If you have any questions, do not hesitate to ask them into the comments below. Thank you for your attention. That was Hervé Barreau on the behalf of the Eventlet Removal initiative.